For any experiment, there are different designs that can be used to collect the data, and these are called experimental designs. And the design that's best for a specific scenario is dependent upon the specific situation as such. There are multiple features that differ between designs. This include whether each independent variable has two levels or more, whether one or more independent variables is being manipulated, and whether the same or different subjects participates in different conditions as defined by the independent variables. The first experimental design is the two-group design. So in a two-group design, one independent variable is tested with only two conditions or levels of independent variable. So in the classic two-group design, a control group gets no treatment. In our example, it's basically the driving without using a cell phone. And then you do have the experimental group who gets some amount of independent variable that's basically driving using a cellular phone. And the dependent variable is going to be the same across two groups. That's basically the lane deviations. However, in human factors engineering, we often compare two different experimental treatment conditions such as performance using trackball versus using a mouse. In these cases, control group is not required. A control group to compare with mouse and trackball users would have no cursor control at all, which does not make any sense. The next set of experimental designs are basically the multiple group designs. Sometimes the two group design does not adequately test our hypothesis of interest. We would want to study one independent variable and would want to evaluate the many levels of the variable as such. So for example, if we want to understand the effect of brightness on display perception, we might want to evaluate several different levels of brightness as such. So if we used 5 different brightness levels and therefore 5 groups, we would still be studying one independent variable. We would gain much more information than if we used 2 levels or groups. With this design, we could develop a quantitative model or equation that predicts performance as a function of brightness. And again, this is an example of a multi-group design. And then you do have factorial designs. So a multi-factor design, it evaluates two or more independent variables by combining different levels of each independent variable. So the term factorial here indicates that all possible combinations of independent variables are combined and evaluated. So let's talk about an example. So let's say we talked about an example of a person who is driving using a cell phone and driving without using a cell phone. So again, you do have one independent variable that's basically driving uh, driving without using a car phone or with using a car phone. And the other one, let's add one more independent variable called the traffic. So you're driving in light traffic or heavy traffic. So a researcher wants to evaluate the effects of using a cellular phone on driving performance, and the researcher manipulates the first independent variable by comparing driving with and without the use of cellular phone. And the researcher suspects that the driving impairment may only occur if driving is taking place in a heavy traffic. So that brings the second independent variable. So he needs to add the second independent variable that consisting of light and heavy traffic conditions. So over here you do have two independent variables. One is basically the usage of car phone and the other one is the traffic level. So the traffic level, the independent variable traffic level has got two conditions, driving in light traffic and driving in heavy traffic. And the usage of car phone independent variable has got two levels, driving without using a car phone and driving by using a car phone. And again, this is an example of a factorial design, and we'll be able to look at the effect of driving in heavy traffic when using a car phone and when driving in light traffic when using a car phone, and we'll be able to identify its differences, the differences in human performance when they drive while using a car phone and not using a car phone in light and heavy traffic conditions. So adding independent variables has got multiple advantages. The first advantage is that it allows designers to vary more system features in one single experiment. It's very efficient to say. It also captures a greater part of the complexity found in the real world, making the experimental results more generalizable. So you'll be able to generalize the results because you do have multiple independent variables and you're trying to emulate a similar kind of environment as the real life. And it allows experiments to see if there's an interaction between the independent variables in which the effect of one independent variable on performance depends on the level of other independent variable as such. So now let's talk in terms of the participants who are experiencing the different conditions as such. So the first one is basically the between subject experimental design. So in a between subject experimental design, you do have different sets of people who are experiencing the different conditions. So let's talk about the example that we talked earlier. You do have people who are driving in without using a car phone, without using a cell phone while driving, and they are using a cell phone while they're driving a car. So again, if you do have participants who are experiencing only one of the conditions, then it's called a between subject experimental design. So let's say you have got 20 participants and 10 participants experience driving in a driving while using a cell phone, and you do have 10 different set of participants who are experiencing the condition while they are driving by using a cell phone. Then that's an example of a between subject experimental design. Now, however, if you do have 20 participants and all the 20 participants experience both driving in a car using a cell phone and driving in a car without using a cell phone, that's an example of a within subject experimental design. In factorial designs, each independent variable can either be between subject or within subjects. So if you do have a few set of participants who are experiencing all the conditions, and if you do have a few set of participants who are experiencing only a few conditions, that's an example of a mixed design. And then you do have experimental designs that involve multiple dependent variables. And we may want to measure how causal variables affect different dependent variables. Now, for example, we might want to measure how the use of a cellular phone affects a number of driving variables, including deviations from the lane, reaction time to brake for cars or other objects in front of the vehicle, time to recognize objects in the driver's peripheral vision, speed, acceleration, and so on. Then you do have multiple dependent variables that you're measuring, and that is an example of a multiple dependent variables used in an experimental design as such. So a key thing that you need to keep in mind when you're selecting the participants and context is that the participant should represent the group that the researcher is interested in. One way to make sure all groups are equivalent is to take an entire set of subjects and randomly put them in one of the experimental conditions. That way, on an average, if the sample is large enough, characteristics of all the subjects will even out across the groups. And again, this procedure is called a random assignment. So when you do have the within subject experimental design, meaning every participant is going to experience all the conditions, many a times you do have what we call an order effect. That means the order in which a subject or a participant receives his or her experimental condition creates a bias. So you need to make sure that you have got um, techniques like counterbalancing that are used primarily to minimize these order effects. So when people participate in several treatment conditions, the dependent measure may show differences from one condition to the next simply because of the treatments or levels of independent variable as experienced in a specific order. For example, let's say you do have a participant who is looking at 5 different cursor control devices in an experiment, and they might be fatigued by the time they are tested on the fifth device and therefore exhibit more number of errors and slower times. This would be due to the order of the devices used rather per the device per se. In contrast, if the cursor control task is new to the participant, he or she might show learning and actually do best on the fifth device tested, not because it was better, but because the cursor control skill was more practiced. So these order effects of fatigue and practice in between subjects designs are both potential confounding variables. Hence, you need to have interventions in place primarily to minimize these things. And researchers typically use a technique called counterbalancing. This means that the different subjects receive treatment conditions in different orders. Now, for example, half of the participants in a study would use trackball and then a mouse. The other half would use a mouse then a trackball. These are all specific techniques for counterbalancing order effects. And one type of counterbalancing technique that is used is called the Latin square design, whereby you basically do have a completely balanced counterbalance design. That way, you do have at least one participant who has gone through the different potential orders that you have in place. That way, you are minimizing the potential effect due to the order in which participants see the different conditions as such. So finally, when you're conducting the data analysis, you do have two different ways of analyzing the data. You do have the descriptive statistics and the inferential statistics. Descriptive statistics are a way to summarize the dependent variable for the different treatment conditions, while inferential statistics tell us the likelihood that any differences between the experimental groups are real and not just random fluctuations due to a chance. And the examples of descriptive statistics include mean time taken, the mean number of errors, and the mean satisfaction score. Whereas in the case of an inferential statistics, you basically conduct a statistical analysis and you will find that participants made statistically significant lesser number of errors with a specific interface when compared to a different interface as such. And for a typical two-group design, the inferential statistical test used is a t-test. And for more than two groups, we basically use a technique called analysis of variance or ANOVA. So a key thing that you need to keep in mind when you're conducting the inferential statistics is basically the sample size. So a greater sample size give our experiment a greater statistical power to find the significant differences. And there are uh, techniques that are available in place to identify the adequate number of participants that you need primarily for a study to understand the differences between the two conditions as such. And this is basically called a power analysis. And there are certain ethical issues that you need to keep in mind when you are using human subjects as participants for your research study. So at Clemson University, we have got the Institutional Review Board that basically monitors all the research studies involving participants. So when people participate in an experiment or to provide data for research by other methods, we need to tell them the general nature of the study. Often they can be told the exact nature of the hypothesis just because if we tell them the exact nature of the hypothesis that might bias their behavior. Now, however, we need to inform the participants of the potential benefits and the potential risk associated with the study. And again, we should tell the participants that all the results will be kept anonymous and confidential. And again, there are a few guidelines that basically advocate a few principles when you're conducting studies involving human subjects. And again, we need to make sure that we do have protection of participants from mental or physical harm. The participants do have the right to privacy and we need to respect their behavior. And we need to make sure that participation in the research is completely voluntary and we need to make sure that the participants clearly knows that. And again, the right of the participants to be informed beforehand about the nature of the experimental procedures need to be kept in mind. And again, you need to have interventions in place. Again, a consent form or something on those lines, primarily to inform the participants of the potential risk and the nature of the experimental procedures that they will undergo for the specific study as such. So they are typically asked to sign a form called the informed consent form. It states that they understand the nature and the risk of the experiment or data gathering project and their participation is voluntary and they understand that they may withdraw at any time. So in human factors field, the experiment is considered to be reasonable in risk if the risks are no greater than the one that are faced in the regular job environment as such. So at Clemson University, we do have the Clemson University Institutional Review Board, and you can go to this particular URL to understand the compliance requirements that are required by researchers when they're conducting studies with human participants.